Hey, welcome back to the second part of lecture on water, on resources we use, where we're going to talk about water. Um, the first thing I'm going to talk about is basically just fresh water. And so fresh water is obviously the water that we use that's drinkable, right? It seems abundant, but drinkable fresh water is actually quite rare. Um, Fresh water is water that is relatively pure with few dissolved salts. Water that is basically drinkable. We can't drink ocean water. Most of it is tied up in glaciers and ice caps and underground in aquifers. So if you look at all of the water on the planet, 97.5% is for oceans, 2.5% is freshwater. If you take that 2.5% of freshwater, 79% of that is tied up in ice caps and glaciers. 20% groundwater. Only 1% of the 2.5% is available surface um, uh, fresh water. And an even smaller part of that is available to us because here it's in lakes, but some of it is taken away in moisture, soil moisture, or atmospheric water. Um, so really the point here, you don't have to know these numbers, but that the amount of fresh water on the planet, while there's water everywhere, is actually uh, fairly rare. We don't have to know the whole hydrological cycle, but basically, the Earth is not creating new water. It is just recycling water via this cycle. So water evaporates, goes up, it rains down, it goes in the ocean, it goes in rivers. This is one of the ecosystem services that nature provides for us. It cleans our water for us, and humans have affected almost every flux, reservoir, and residence time, which means how long something stays in a particular part of the water cycle. So we've had great effects on the water cycle. And again, we are not making new water. The earth is just recycling our water. And human activities affect waterways. Water is limited, but a renewable resource as long as we use it sustainably. It's not renewable everywhere at every time. It's not like nature says, oh, you took water out of that I'm going to rain some down for you. People are withdrawing water at an unsustainable rate, especially with concerns to depleting groundwater, but also surface water from lakes. 1/3 of the world's people are affected by water shortages. It is kind of a harsh reality that generally, if you live somewhere where water is scarce, water is more expensive for you than if you live somewhere where water is plentiful. People also engineer waterways. They put up dams, levees, diversion canals for supplies, transportation, and flood control. One of the largest dams in the world, the Three Gorges Dam in China. You can see the before and after satellite photos. So basically, when you put up a dam to create a reservoir and also for hydroelectric power, you create a big lake behind it and you flood the area. So in China, they moved people out. They can do that because it's a communist government, so they can just move people whenever they want, move them out, and created this big reservoir. But we've permanently modified landscapes. A lot of dams now are being removed because they are only providing a small amount of electricity. These smaller dams, and they're affecting waterways. This is the Condit Dam up in Oregon. You can actually Google it and watch that dam being removed. It's pretty interesting. But water is unequally distributed across the earth, and we know this, right? There's less water in deserts, there's more water in the rainforest. And so while this correlation between water and people used to really go with population, that's changing with our ability to move water around. In Southern California, we bring in a ton of water that doesn't come from here. So what are we using our water on? 70% of our water is used for agriculture, crop irrigation, watering of livestock, and then 20% goes to industry and 10% for residential use. That 20% bullet should be popped out the other way. I apologize. But, when people talk about reducing water in our homes, that's really good for sustainability, but we really need to get better at our water use for agriculture in order to really improve how much water we're using. There are two types of water use. There's consumptive water use, and that is when water is removed from an aquifer or surface water body and is not returned. That's most of our water use, right? We take water out, we use it, and then it winds up somewhere else, right? We use it for drinking water, we move it for farms, we do something else. So it's not going back to its source. Non-consumptive use is a much smaller portion. So that if you're going to pipe some type of water in order to cool a system at a power plant and then pump that warmer water back out, which I'll talk about, that can have its own issues. But that's non-consumptive use. So it does not remove, it only temporarily removes the water. And we can have some pretty great effects on water supplies. This is the Aral Sea, which the Aral Sea was an inland sea, kind of like the Great Salt Lake. There was a kind of a vibrant fishing industry there. And what happened is they started diverting water off of it to grow cotton. There's not a lot of rain here, but there's a lot of sunshine. And so they took all this water to grow cotton and they quickly drained the sea. You can see the historic extent of the sea here and what is left, not very much, right? This is in 2014. And this was like the size of San Diego County. This was not a little body of water. So we can really have profound effects on waterways. We recently experienced a drought. This is Lake Oroville in 2011 versus 2014, right? Pretty dramatic difference in the amount of water that is in Lake Oroville. But then if you look at this picture from 2016 to 2017, right, we were able to have a very wet year and pull ourselves out of that drought. So the point being is that water is not renewable everywhere all the time. And so our uses can have pretty great effects. And when water disappears for a while, it really affects us and local ecosystems. There is going to be a link to this video outside of this PowerPoint that you're going to watch next, but it's about New York City's water supply system and how, New York City did something kind of amazing, and they protected their watershed rather than installing a filtration system. So they bought land upstream in order to protect that watershed. New York City has naturally filtered water and some of the best water in the country. And you're going to watch a little thing about that after you watch this lecture. But we also, we pull a lot of water out of groundwater systems, particularly the Ogallala Aquifer, which is a humongous aquifer that spans from South Dakota all the way down to Texas and to parts of New Mexico. But basically, we are draining that water really fast for agriculture. And the land is subsiding, so the land is actually sinking from that. That's what this map is of. And groundwater takes a really long time to recharge. So once that water is gone, it is not going to recharge fast enough for us to keep using it. And if you look at the growth of Las Vegas, you can see the water depleting in the time lapse, right? We really can profoundly affect bodies of water in relatively short periods of time, right? So water is a renewable resource, but not everywhere or all the time. And serious problems can happen even if depleted for a short time. So you can imagine how disturbing it would be to come into your house and turn on your faucet and not have any water, right? We kind of really take that for granted. So where does our water in Southern California come from, right? We have lots of green lawns and golf courses in Rancho Bernardo and lots of agriculture out in the Imperial Valley. Partially from the Colorado River. We have senior water rights over the Colorado River. We take a lot out of that. Some comes from the San Joaquin River Delta. Some comes from snowpack from the Sierras. And if we have bad snowpack, that really affects how much water we have available to us. And then desalination, which there's a desal plant in Carlsbad that is operating now. But desal, which I'm going to have you do a little bit of research on in order to complete your exercise. And you're going to tell me why desal may or may not be sustainable. I'm not going to talk about it because I want you to talk about it. We also do wastewater recycling. So we will take gray water, which is kind of used water, we will clean it, and then we will use it for irrigation. So if you see a sign that says reclaimed water, this is recycled water. We use very little from groundwater. We don't have a ton of groundwater here, and some of the groundwater we have here has naturally occurring arsenic in it, so not very good for us at all. But we use it for agriculture, is most of it in Southern California, followed by landscaping, and then followed by in our homes and businesses. So again, when we are thinking about water reduction, in our home is great. But most people in their home save the shorter shower, doing that type of things. We have very efficient toilets, generally speaking, especially in newer homes. Most of us have learned not to leave the water running unnecessarily, especially in Southern California, or people are kind of landscaping their properties in order to be more efficient with water. Right, and so you are going to read some about desal. A lot of people think that desal should be the answer to things, um, but I would like you to research kind of why that might not be true. And then also toilet to tap, which again is that reclaimed water. We have a cultural aversion to toilet to tap. We shouldn't call it toilet to tap, but we have the ability to take wastewater and clean it so it's purer than the water that comes out of our faucet right now. But there's kind of an aversion to using that reclaimed water. We only use it um, for landscaping right now. And really, there is no reason not to use it. And it's kind of ironic because I told you in the beginning that all of the water we have now is all of the water that we have anyways. So if somebody cleans water, throws it back into a river, and you pull it out later down in the river, nothing magically happened to it in between that time. Also, bottled water is really unsustainable and has heavy ecological costs. So, groundwater is being withdrawn for bottled water. An average American drinks 29 gallons a year of bottled water. And people do that for portability and convenience and health. There is much more of a trend than when I first started teaching to have your reusable water bottle with you. But the energy costs are 1,000 to 2,000 times greater than with tap water, including managing the bottle, or manufacturing the bottle, excuse me, transporting the product. 75% of the bottles are thrown away and not even recycled. This is my one thing, if Fiji Artisan Water sues me at some point, but this is dumb, right? We ship water from the islands of Fiji in plastic bottles, um, thousands of miles. And actually, Conservation International has kind of paired with Fiji water to try to do some conservation stuff on the island to benefit that, but I'm still really not. I'm not a proponent of shipping water very far away in plastic bottles. That's not really good for you anyways, kind of leaching all types of stuff into your water bottle. The other thing that I want to talk about is water pollution. So issues with sustainability of water are not just about how much water we use, but what we are putting in our water. There are all types of, this is from an old textbook that I used, but there are all types of water pollution, right? You can get fertilizers and nutrients and salt and industrial waste, oil spills, right? This poor river is in trouble with the amount of stuff that is right on it. But I'm going to talk about kind of the two different types of pollution, two main categories of pollution, and that is point and non-point source pollution. So pollution is just the release of matter or energy that causes undesirable impacts on human health and the on health and the well-being of humans or other organisms. So point sources are discrete locations of water pollution. And what I mean by that is there is something in the water and you can point to the direct source, right? A sewer pipe, a factory, an oil tanker. I can point to that direct source and say, that guy is putting this stuff in the water. That is my point source pollution. And most of that was addressed by the US Clean Water Act. The harder one is non-point sources of pollution, and this is where you have multiple inputs of pollution over larger areas. So when you have runoff over farms or cities or streets or neighborhood, and you have chemicals from your car that are on the street, and then it rains, and then it gets into waterways, right? You can't point to one specific spot, and those are much, much more difficult to deal with. We also have a lot of different types of pollution. Something we have is nutrient pollution, which is when you get fertilizers from farms or sewage, lawns, golf course, Basically, that fertilizer runs into a waterway, and then it causes a bunch of algae to grow, and it leads to something called eutrophication and hypoxia. But basically, that algae chokes out the rest of the wildlife that's in a body of water. So you get these massive algae blooms, and then everything else dies. And then problems with biodegradable waste. Um, Human waste, animal manure, paper pulp, yard waste. Basically, they decrease the amount of dissolved oxygen in the water, but comes from toilets, sinks, dishwashers, washing machines, industrial cleaning processes, stormwater runoff. And also, some nations treat their wastewater, but some do not. Depending on where you are in the world, people might wash their dishes and immediately just throw that soapy water or that dirty water or that industrial water right back into the waterway. One of other points of pollution in water, which I'm mentioning mainly because I do a lot of research in fisheries, is actually aquaculture, where aquaculture is fish farms basically, right? So we take fish which are running out in the ocean, and instead we breed them in these pens. But fish like salmon, which you can buy a lot of farm salmon, actually produce a ton of waste. A farm with 200,000 salmon discharges more fecal waste than a city of 60,000 people. And that is going straight into the water without treatment. We also have issues with toxic chemicals such as pesticides, petroleum products, or synthetic chemicals. Toxic metals, arsenic, lead, mercury, acid rain, acid drainage from mines. And those effects include poisoned animals and plants, altered aquatic systems, and human health problems. And so, what are some of the solutions? We need to issue and enforce more stringent regulations on industry, or modify industrial processes, or modify our purchasing decisions, right? We do want to buy from people who are polluting water. Very often, this pollution is happening in other countries. So we are buying a product that is actually being quite polluted, you're polluting somebody else's water because your thing was manufactured in another country. But it does happen in the US. Drinking water for 15 million Americans is contaminated with a toxic chemical. This report found in 2017. And not to mention the Flint water crisis, which is still happening. The people of Flint are still having problems with their water, and I'm going to have you watch something about the Flint water crisis as well. But we have the Clean Water Act, which, it protects more than water. It protects, health and human well-being. So rolling back protections on the Clean Water Act would not be good for our waterways. I've shown you in the past, we literally had waterways that we used to be able to set on fire. We also have issues with sediment pollution, which is basically erosion. So you have soil that's running into waterways that is clogging up waterways. So if you do clear cutting of forest or mining, or you clear land for housing, you basically increase erosion. Same thing with farms. So we need to adopt better soil practices, kind of avoid these large scale disturbances of vegetation. And we need to keep the vegetation on the shoreline because that acts as a trap for sediments. And then also thermal pollution. Thermal pollution, so this is a picture of San Onofre, which is no longer operating. But thermal pollution is water that is too warm or too cold. And so when I talked about that non-consumptive use of water before, if you take water in to cool something and then you release it back out at a higher temperature, you can have a lot of problems there. Warmer water holds less oxygen. And removing streamside cover in addition, so removing that riparian or right next to the river vegetation, you're exposing it to more sunlight and you can raise the temperature. Water that is too cold also causes problems. Water at the bottom of reservoirs behind dams is colder, and that can cause harm when it's released. Most wildlife has very specific temperature restraints, and so we can really damage those ecosystems when we release water that is too warm or too cold into that ecosystem. Also problems with groundwater contamination in Bangladesh. There is a lot of water all around, but not a lot to drink. And so as a way to combat that. They dug a bunch of wells, but a lot of these wells were actually are now unusable because there is naturally occurring arsenic that happens in the soil. So people were getting sick from that groundwater. Groundwater can also be contaminated in a variety of other ways. Um, if people are very worried about hydraulic fracturing contaminating groundwater. That is the end of the second half of the lecture on resources for this module.